All right, eighth grade, we're going to go ahead and return to chemical bonding, which we started talking about on Friday. When we left off on Friday, we were talking about valence electrons, or certainly we were in 8A. 8B, if you want to skip ahead to question 5, you're certainly welcome to do that. We talked about valence electrons being those loosely held electrons in the outer energy level of an atom. These are the electrons that really affect chemical bonding or chemical reactions. And so 8A anyways, we left off getting ready to talk about question number 3. How can you use the periodic table to predict valence electrons? Well, generally, you can actually look at the group numbers on the periodic table. And this is just kind of an extra piece of information, really. It's not a critical piece for what we're talking about right now, but we will soon be talking a lot more about the periodic table, and so I think you'll find this to be helpful a little later on as well. So if you take a look at the group numbers are basically the numbers for each column in the periodic table. You can see them here. In groups 1 and 2, the number of valence electrons matches the group number. So all of these elements here, lithium, sodium, potassium, rubidium, cesium, and francium, each of those has one valence electron. This makes them very highly reactive. They would like to get rid of that one valence electron. So they tend to react very quickly with other elements, especially those that need one valence electron. In group 2, there are 2 valence electrons. If we skip over here to group 13, 14, 15, 16, 17, and 18, the number of valence electrons matches the ones digit in the number. So group 13 has 3 valence electrons, group 14 has 4, 15 has 5, so on and so forth. Here in the middle, groups 3 through 12, unfortunately, there really is no formula for figuring out exactly how many valence electrons they have. Question number 4, what makes atoms unstable? Well, we've kind of touched on this. Incompletely filled valence electron shells are what make them unstable. They want to have a full valence shell. That outer shell wants to be full. Atoms are stable when they have either 0 electrons in that outer level or they have 8. And then they go ahead and gain, lose, or share electrons in order to either empty out or fill that outer level. Question number 5, what is chemical bonding? Well, it's when atoms of one type form with another type of atom to form new substances. And actually, I stated there that it's atoms of different types joining together. That's not necessarily true. Chemical bonding can happen when, say, 2 oxygen atoms bond together, or 2 fluorine atoms bond together. So, question 6, why do atoms bond? Well, they want to be stable. All things in the world want to be stable. They want to reach a state of equilibrium. And it's the same thing with atoms. They don't want those unstable valence energy levels. So what is the chemical bond? Well, it's actually the force that holds 2 atoms together. It's not an actual product or an actual item. Instead, it is a force that holds atoms together. So let's take a look at an example. Here you can see some sodium. Sodium is actually a metal. It's a very soft metal. You can see here on the left that you can actually cut this metal with a knife. So it's a very soft metal. It's also a very explosive or reactive metal. on the right-hand side, you can see a reaction that happens when sodium is put into water. So if we were to take sodium and put it together with chlorine, which happens to be a toxic green gas, so we take kind of a silvery whitish soft metal, we combine it with chlorine gas, and here you will see a very slow motion reaction of what happens, and you end up with table salt. So the end product after that very violent reaction is table salt that you can eat. We take a metal, which we certainly can't eat or consume. We take chlorine gas, which is absolutely poisonous to human beings. You put those two together and you end up with table salt, a substance that we need in our daily diets in order to survive. Question number 8 asks, what are 3 ways that atoms can form bonds? Well, there are 3 kinds of bonds that we are going to be talking about. One is called ionic bonds. The second one is covalent bonds. And the third would be metallic bonds. So let's start to take a look at each of those 3 and find out what they are. So number 9 asks, how does an ionic bond form? Well, an ionic bond forms when valence electrons from one atom are transferred to another atom. So if an atom loses one electron because it gets stolen, so to speak, by another atom, then each of these atoms becomes a charged particle. The one that lost the electron becomes positively charged. The one that gained the electron becomes negatively charged. Now you have a positively charged particle and a negatively charged particle. We know that opposites attract, and therefore the positive and negative charged ions are attracted to each other and they form a bond. One example would be the sodium chloride or the table salt that we just looked at. Sodium happens to have 1 valence electron. Chlorine happens to have 7. Sodium would love to get rid of that 1 valence electron. Chlorine desperately wants 1 more valence electron. And so chlorine steals that valence electron from sodium. Sodium becomes positively charged, chlorine becomes negatively charged, and the 2 atoms are attracted to each other and form a bond. And when that bond happens, then we have table salt. Here we can see that in another example where we see sodium with its 1 little lonely valence electron over here. We can see that chlorine is missing a valence electron right over here, so it steals it away. Therefore, sodium becomes positively charged, the chloride ion is negatively charged, and they are attracted to one another. Here's a little, very little, chemistry humor for you. What do you call a chemical bond that is sarcastic? An ironic bond. Okay, moving on. Let's take a little bit of a look at ionic bonds for just a minute in a little more animated way. Here again, we're using that example yet again of sodium chloride. Sodium with its 1 valence electron, chlorine with its 7. Chlorine steals that electron from the sodium. 1 is positive, 1 is negative. They attract and the bond is formed. This can also happen with magnesium and oxygen. Magnesium happens to have 2 valence electrons and oxygen has 6. Oxygen would like 2 more. Magnesium would love to give up those 2. And so that happens. Magnesium becomes positively charged by 2. The oxygen becomes negatively charged by 2. And they attract and form a bond. Can also happen with magnesium and chlorine, but it's not quite as obvious. Magnesium, again, has those 2 valence electrons. Chlorine, on the other hand, has 7 valence electrons. It only needs 1 more. Well, if chlorine gets another chlorine atom involved in the process. Then suddenly 2 valence electrons are needed. We've got magnesium with a positive charge of 2, chlorine -1, chlorine -1. They attract, and we have a chemical formula now of MgCl2. All right, magnesium chloride. Same type of thing with aluminum and oxygen. You can see here the sharing that goes on and the attraction or bonding that happens for Al2O3. Question number 10 asks, what is a compound? Well, a compound is a substance. It's made up of 2 or more different elements, and the properties of the compound are different from the elements by themselves. So sodium chloride or table salt is completely different from the metal sodium and the poisonous gas chlorine. Question 11, what is a chemical formula? We've just seen some chemical formulas on the last few slides. So chemical formula is basically just a shorthand way that we use symbols and numbers to represent a substance. For instance, H2O represents water because it has 2 hydrogen atoms and 1 oxygen atom that have been chemically combined together or bonded together. O2 is when 2 oxygen atoms have bonded together. Glucose, a form of sugar, C6H12O6. So we have carbon, hydrogen, and oxygen bonded together, 6 carbons, 12 hydrogens, and 6 oxygens. These are all chemical formulas. You have to be careful the way that you write chemical formulas. All 3 of these look very similar. They have C's, they have O's in them, but they are all extremely different items. Capital C, lowercase o is the element cobalt. Capital C, capital O is carbon monoxide, poisonous gas. Capital C, capital O2 is carbon dioxide. Also a somewhat poisonous gas, but in a little bit different way. So all very different things, but their chemical formulas look similar. So you have to be careful when using chemical formulas. Here's just a couple of more examples. Sodium chloride, magnesium chloride, and several more that you can take a look at and see. Our next question is, what is a covalent bond? So we've talked about what an ionic bond is. What is a covalent bond? Well, a covalent bond is formed when 2 atoms share electrons. So with ionic bonds, we had some thievery going on, some stealing. With covalent bonds, it's all about sharing. Okay, so let's take a look. Here we've got 2 atoms that are going to be able to share 2 electrons, so that now by sharing those 2, those electrons are going to be in the valence energy level for both atoms. They're going to count twice, so to speak. Now their valence electron levels are full. Same thing happens with water, H2O. There are 2 covalent bonds in H2O because there are 2 electrons being shared by 2 different atoms. It also happens with nitrogen and hydrogen. Forms ammonia. Happens in carbon dioxide and dinitrogen monoxide as well. What is a molecule? Well, a molecule is atoms that have been joined together by a covalent bond. And as with a compound, the properties of the molecule are different from the atoms when they were all by themselves. Water, again, is an example. So is table sugar.